part, pressure of ideal gas. When pressure of ideal gas, when gas is enclosed in a container, at that time it is observed that gas molecules are in state of random motion. These molecules are moving in all directions. Then there are collisions between the molecules always. Also there is a collision between the molecules and the walls of container. Now when it strikes on the or hits on the walls of container, it exerts the pressure on the wall of container. When we are enclosing the gas in a container, actually it exerts the pressure on the wall of container. And now we want to find this pressure which is exerted on the wall of container, and it is known as the pressure of ideal gas. तर आपण प्रेशर ऑफ आयडियल गॅस जो आहे तो आपण फाइंड आउट करणार आहोत. तर केव्हा गॅस जर एखाद्या कंटेनर मध्ये एन्क्लोज केला तर तिथे काय असतं, तर थोडक्यात देयर इज अ कोलिजन, इंटर मॉलिक्युलर कोलिजन. मॉलिक्युल्स मध्ये सुद्धा एकमेकांशी हे मॉलिक्युल काय होतात, कोलाइड होत असतात. ॲज वेल ॲज these molecules are collide with the walls of container. हे walls of container से सुद्धा काय होतात, collide होताना दिसतात. But these collisions are elastic, means there is neither energy is created nor energy is destroyed, or there is no loss of energy or gain of energy during this process. तर energy देवाणघेवाण याच्यामध्ये होत नाही. That's why these are called as the elastic collisions. Now consider the n moles of gas. Now consider n moles of gas. It is kept in a cubical box. It is taken in a cubical box. Now volume of this cubical box is V is equal to L cube, in which L is the length of each of this box, length of each side of this box. Now V is the volume of this cubical box. It is equal to L cube. Now L is the length of each side of this cubical box. Also suppose L is the mass of molecule. Now it consists the n number of molecules. याच्यामध्ये जे आहे ते मॉलिक्युल्स किती असतील, n number of moles. The small n indicates the n number of moles. It consists the n number of moles. Also, there are a number of molecules. There are large number of molecules. Number of molecules are still large number of molecules. Actually, these are we can consider as the n, or we are taking this in the form of velocities. Velocity च्या form मध्ये आपण number of molecules घेत असतो. Now n is the mass of this molecule. Now these molecules are in state of random motion. When it is enclosed in a container, all molecules are in state of random motion. Therefore, there are intermolecular collisions. Molecular collisions means what? There are collisions between the molecules. This number of molecules collide with each other. Also, these are hitting to the walls of container. But this number of collisions or this collisions depends upon the pressure of the air. When pressure is larger, there are a large number of collisions. But this pressure is so adjusted that that's why we can neglect the intermolecular collisions. Collisions between the molecules are neglected, and there are collisions between the molecules and the walls of container, and these collisions are elastic collision. And when these are incident on the walls of container or collides with the walls of container, they exert the pressure on these walls, and we want to find this pressure. Now consider one molecule, or consider a typical molecule of mass m. Consider typical molecule of mass m. It is moving with velocity v bar. It It is moving with velocity v bar. एक टिपिकल मॉलिक्यूल आपण सिंगल मॉलिक्यूल कन्सिडर केला तो की कोणत्या वेलोसिटीने मूव्ह होतो v बार ह्या वेलोसिटीने मूव्ह होतो. But this v bar is split into three components. Means it is this molecule can sometimes move along x axis, along y axis, sometimes it can move along z axis. That's why this velocity is split into three components. Velocity along x axis, it is called as the x component of the velocity. It is represented by vx. X component of y component of velocity. Y component of velocity. Now this is the vx, x component of velocity. Vy is the y component of the velocity, and vz is the y component of the velocity. Now this actually these are the small v's velocities. That's why we can represent by small v. Now these are split. This velocity is split into x component, y component, and z component. Now these are the different components of the velocity v bar along x axis, along y axis, and along z axis. Now this molecule is moving with velocity v so as to collide with the, so that it collides to the shaded face. Now this shaded face is parallel to the yz plane. This shaded face जे आहे ते yz plane ला काय parallel आहे. Actually this cube now sides of this cube are along the x axis, y axis, and z axis. ये sides जे आहेत काय आहेत along x axis, along y axis, and z axis आहे. Also temperature of this faces or sides is kept constant. Temperature सुद्धा ह्या faces काय असेल constant असेल, because we know as we increase the temperature or decrease the temperature, speed of gas molecules increases or decreases. That's why temperature of this cubical box is kept constant, or temperature of faces is constant. Now consider a typical molecule is moving with velocity v. Now when it is considered as when it collides with the shaded face, when it collides with the shaded face, only the x component is reversed. Only x component of velocity is reversed, and other components vy and vz, means y component and z components are not altered. काय कन्सिडर केलं हे ज्यावेळेस याच्यावर कोलाइड होईल त्यावेळेस फक्त व्हेलॉसिटी अलॉंग एक्स ॲक्सिस काय होते रिव्हर्स होते. व्हेलॉसिटी अलॉंग वाय ॲक्सिस आणि झेड ॲक्सिस हे काय झाले त्याला कंपोनेंट्स ऑफ व्हेलॉसिटी अलॉंग एक्स वाय ॲक्सिस आणि झेड ॲक्सिस दीज आर नॉट अल्टर्ड. हे दोन्ही जे आहेत ते आपल्याला बदललेले दिसणार नाहीत. थोडक्यात जेव्हा इथे कोलाइड होईल तो बरोबर ज्यावेळेस हा मॉलिक्यूल इथे कोलाइड होईल या फेसला, समजा ह्या फेसला कोलाइड झालं इथे अशा पद्धतीने, नाउ दिस इज दी shaded face, shaded surface. When this velocity when molecule collides with this face, at that time this velocity only velocity along x axis is reversed. Only velocity along x axis is reversed. Otherwise this along y axis vy remains same, and this vz is also remains same. Only the vy is reversed in backward direction. फक्त vx काय झालेले इथे रिव्हर्स झालेले असं आपण कन्सिडर केलेले. vy आणि vz हे चेंज झालेले. Now this typical molecule is moving with velocity v bar. Now when it incident on the shaded face, or when it is collide with the shaded face, only the x component of velocity is reversed. Y component of velocity and z component of velocity is not reversed. Now it is generally we consider this as the single molecule, but in case of all molecules also, In case of all molecules also, Vz and Vy are not altered. Means average of Vx, Vy and average of V0, average of components along y-axis and average of components along z-axis of the velocity not altered. Only there is a change along the x-axis. In other words, we can say that actually these molecules are evenly distributed throughout this container, but still there is no displacement along plus y or negative y or along plus z or negative z. म्हणजे थोडक्यात इकडे झेड असेल, इकडे काय असेल निगेटिव्ह. म्हणजे इथे आपण कन्सिडर केले इकडे तिकडे ह्या डायरेक्शनला कुठेही आपल्याला वेलोसिटी चेंज झालेली दिसणार नाही. देयर इज ओनली द चेंज अलॉंग द एक्स ॲक्सिस. एक्स ॲक्सिसच्या अलॉंग काय झालेलं असेल, चेंज झालेलं असेल. नाउ वी वांट टू फाइंड द प्रेशर. फॉर दैट there is a requirement of force, and this force is obtained by obtaining the momentum. तर momentum obtain करून आपण काय फाइंड आउट करू शकतो, फोर्स. आणि फोर्स अपॉन एरिया जे आहे, फोर्स अपॉन एरिया म्हणजेच काय असेल, तुमचं प्रेशर आपल्याला फाइंड आउट करायला मिळेल. मग त्या पहा कन्सिडर मॉलिक्यूल इज वेट मॉलिक्यूल इज मूविंग from this place toward this shaded region. Its mass is here. It is moving with velocity v bar. Now this v bar, when it is after collision, this velocity along x-axis, this velocity is resolved into three components. Along x-axis vx, along y-axis vy, and along z-axis vz. And when it collides, after collision, only vx is reversed. Vy and Vz are not altered. Now in this case we get this rate of change of momentum or average. And thus there is a change in only the x component of the velocity. Therefore we can find the average change in momentum or average change in momentum in the x component of the velocity, and it is equal to what? It is equal to final momentum minus initial momentum minus initial momentum. But this delta px is equal to, now momentum means it is the product of mass and velocity. Now initially when it is starting, it's from this place, m is mass and vx is the velocity. Therefore initial momentum is mvx, and final momentum after collision, its velocity is reversed. Its velocity becomes after collision velocity is reversed, which vx is equal to velocity is minus vx. Therefore, but mass of the molecule is same. Therefore we can write final momentum as minus m into vx, and minus we get initial momentum is m into vx, and it is equal to, we get this as the minus twice m into vx. This is the change in momentum. Final momentum minus initial momentum, it is equal to delta px, it is equal to final momentum minus initial momentum, which is equal to minus 2m into vx. This is the change in momentum. Now this momentum is given after collision. This momentum is given to this phase. Therefore this momentum is given to this phase, but this is positive because this is negative. Negative means there is a loss of momentum by the molecule, and it is given to this phase, means this is the gain of momentum by the phase. Gain of momentum by the phase. Therefore momentum given to the phase, given to the this shaded phase, shaded phase, shaded phase, momentum given to the shaded phase or transferred to the shaded phase during collision is equal to twice m into Vx, twice m into Vx. Now this is the twice m into Vx. This is negative and this is the gain of momentum by the phase, and this is the loss of momentum by the molecule. But according to law of conservation of momentum, this momentum is conserved or momentum remains constant. If this is negative, then gain is positive. This is the change in momentum. Now we want to find the average force. Now average force by a single molecule, average force exerted by a single molecule on a shaded region, it is obtained by the rate of change of momentum. Rate of change of momentum. Actually, rate of change of momentum means we are dividing the average change of momentum by the time. We are dividing the this quantity with the time. It is the rate of change of momentum. For that, we have to find the this rate of change of momentum during the time, that is the time required for one collision, but it is not possible to obtain the time required for the single collision. That's why we are considering the time between the two successive collisions. Now consider initially this molecule is this molecule travels from this position, and when it is incident to shaded phase, there is a first collision. After reversing from this phase, again it reaches to this phase, and now after collision with this phase or parallel phase, it again reaches to this phase. Means again it is now again colliding with this phase. It means that there are two successive collisions with this phase, and during this listen again, when it collides with this phase, it returns to this phase, and again after collision, now it reaches to the original position. And during this motion, it covers the distance here. Again, it retraces this path, or it reverses in opposite direction, and again reaches to this phase. Means there are two collisions with this shaded phase. These are the two successive collisions. During these two successive collisions, it covers the distance here, and again it covers this here. Means the distance covered by the molecule, distance covered by the single molecule between two successive collisions with this same phase, it is equal to twice here. Now distance covered in two successive collisions, two successive collisions, it is equal to what? Twice here. Distance covered in two successive collisions, it is twice here. Means length of cubical box is L, therefore it covers two times this distance, and this distance covered is 2 here. Now time taken or time between two successive collisions is delta t. Delta t. Actually it is moving along x-axis, velocity is Vx. From this we know formula for the velocity Vx is equal to distance or displacement upon time. Displacement upon time. Therefore Vx is equal to this Vx is equal to, it is equal to displacement is twice L upon Vx. Displacement is twice L upon delta t. Now time delta t, time between the two successive collisions is twice L upon Vx. Now this is the time between two successive collisions. Time between two successive collisions. Now average force exerted by the molecule 1. Average force exerted by the molecule 1. Now we are finding initially first for the single molecule, and then we are finding on this average value for the all molecules. Now this force the average force exerted on the shaded wall, it is equal to average force exerted on the shaded wall. Suppose this is the F. Average force is this average force is F. This average force is F. Average force is F. Or we can write this average force as the F. Now, by the first molecule, average force exerted by the first molecule, it is represented by F1, or average force is equal to average rate of change in momentum. Average rate of change of momentum, that means average change in momentum along x-axis upon time. Average change in momentum upon time. Therefore, we get this as the average rate of change of momentum. Average rate of change of momentum, and it is equal to change in momentum upon time. That is twice m dx upon time is delta t. It is upon time. It is equal to delta t. It is equal to twice l upon vx, or twice l upon vx. Now by cancelling this l 2, we get this as the force exerted by the first molecule by the x component of velocity. It is equal to m by l. It is equal to m by l into vx square. M by l into vx square. Now this is the force exerted by the molecule, but first it is exerted by the first molecule. Now force exerted by the first molecule, it is represented by F1, and in this case it is the x component of the first molecule. This is the x component of the first molecule, or force, average force exerted by the x molecule of the x component of the velocity, and this is the x component of the first molecule. Now for other molecules, now Vxy, Vx2, Vx3, Vx4, these are the velocities, x components of the velocities for other molecules. Now for all other molecules, we get this as the average force for all molecules. Average force for all molecules. Actually, this is the average of the x components of the all molecules. Average force of the x components of the all molecules, it is equal to total average force. Total average force for all molecules. We get this as the m by l into Vx1 square plus Vx2 square plus Vx3 square plus. Now we get relation as like this. This is the average force. Suppose this is the F. This is the force F. Or instead of F, we can write only this average force for all molecules for the x component. X component. Similarly, we can write the average force for y components of the velocity. Also, we can write the force exerted by the z components of all particles. That is the m by l. Instead of this Vx1, we can write Vy1 square plus Vy2 square plus Vy3 in case of y components. In case of z components, instead of this, we can write Vz1 square plus Vz2 square plus Vz3 square. तर हे जे आहे आपण x component of velocity जे आहे त्याच्यासाठी force exerted by the all molecules and this is the average force exerted by the x components of the velocity. Similarly आपल्याला काय मिळेल average velocity exerted by the y components of the velocity, average force exerted by the z components of the velocity. Now this is the force. After that we can find the pressure. Now average pressure, we know average pressure it is equal to what? P is equal to F upon A, force upon area, but it is equal to m into Vx1 square, m into Vx1 square. तर इथे जे आहे x कंपोनेंट साठीच आपण हे फाइंड आउट करतोय. प्रेशर जो आहे तुम्ही x कंपोनेंट साठीच अगोदर फाइंड आउट करायचा. Vx1 स्क्वेअर प्लस Vx2 स्क्वेअर प्लस Vx3 स्क्वेअर प्लस अपॉन m by l इथला तर आहे. नाउ एरिया ऑफ दिस फेस, area of this face is l into l because it is a cube. Here the cube आहे, therefore length of all sides is same, therefore face is length into breadth or length into height, it is equal to l square, therefore it is equal to l square. From this we get this m upon l cube into Vx1 square plus Vx2 square plus Vx3 square plus. But we can find the mean of this squares of velocity. Mean of this squares of velocity. Actually, this is the mean square velocity. Mean square velocity we can find this as the v square bar, vx square bar. It is equal to vx1 square plus Vx2 square plus or Vx3 square plus upon. Now these are the n number of velocities, therefore we can find the average by dividing with the total number of velocities. तर इथे जे आहे आपल्याला Vx square थोडक्यात इथे तुम्हाला एवरेज व्हॅल्यू जे आहे ते काय मिळेल Vx square bar it is equal to Vx1 square plus Vx2 square plus Vx3 square upon n. म्हणजे ह्या ब्रॅकेटची व्हॅल्यू काय ना n इकडे घेतला आपण, n काय घेतला इकडे घेतला, तर प्रेशर इज इक्वल टू काय ना n Vx square bar, because this is the average is represented by bar. एवरेज घेतो तर तो काय म्हणून रिप्रेझेंट करतो आपण, बार ने रिप्रेझेंट करतो. therefore we get this as the P is equal to m upon, sorry this is small m upon l cube into, instead of this we are writing n into Vx square, n into Vx square bar, n into Vx square bar. Now this is the pressure, but also we can write this in another form as like this. Now this is, we can write this as the this pressure. Now this pressure we can write this as the P is equal to, we know P is equal to mn upon L cube into Vx square bar, Now this is the pressure exerted by the all molecules along the x-axis. Actually, this is the pressure exerted by the x components of the velocity. But we know this Vx square bar, it is equal to Vy square bar, it is equal to Vz square bar. हे दोन तिन्ही कसे असतात, सेम असतात, because average of components of velocity along x-axis is same as the average of components of velocity along y-axis and average of components of velocity along z-axis. But we know this v square bar, that is the velocity average velocity, it is equal to Vx square bar plus Vy square bar plus Vz square bar. Vz square bar. But all these are same. All these are same. Therefore, we can write this as the when we are taking this as the single, then it is Vx square bar, Vy square bar, Vx square bar. This is also Vx square bar because all are same. Therefore, we are comparing with the Vx square only. Therefore, we get this as the 3 Vx square bar. 3 Vx square bar. And by substituting this value 3 Vx square bar, therefore Vx square bar it is equal to, therefore Vx square bar, Vx square bar it is equal to 1 by 3 into V square bar, 1 by 3 into V square bar. Now by substituting this value we get this relation as जे व्हॅल्यू आपण ह्याच्यामध्ये जर ठेवली तर काय येते. Now by substituting this value in the pressure equation, we get this P is equal to ह्याच्याऐवजी काय घेणार आपण 1 by 3 V square bar. Therefore it is equal to mn upon L cube. L cube into actually 1 by 3 it is equal to 1 by 3 mn upon L cube into V square bar. V square bar, and this is the pressure exerted by the gas when it is enclosed in a container. It is 1 by 3 mn into V square bar upon L cube. तर इथे जे आहे आपल्याला प्रेशर जो आहे तो काय मिळेल तुम्हाला 1 by 3 m into n upon L cube into V square bar. Also we can write this as the L cube is equal to V. L cube म्हणजेच काय असेल तुमचं व्हेलॉसिटी व्हॉल्यूम असेल. मग तुम्ही व्हॉल्यूम फॉर्म मध्ये काय लिहिणार इथे P is equal to 1 by 3 this m upon means we can write this as the m into m by mn by V, mn by V into V square bar, mn by V into V square bar. किंवा एक पर्टिक्युलर फॉर्म मध्ये असं जनरली लिहिलं जातं n upon V into m V square bar. Now this is the pressure equation. Finally we get pressure equation as 1 by 3 n upon V into m V square bar. कधी कधी तुम्ही हा V इथे सबस्टिट्यूट केला तर इथून तिथून काय तुमच्या कॅल्क्युलेशन मध्ये V आणि फायनली तुम्हाला अशा इथेच तुम्ही समजा L cube is equal to V कन्सिडर केला तर तो कन्वर्ट कसा होईल m by V. तसंच इथे m by V किंवा लास्टली कन्वर्ट केलं तरी चालेल. आणि इट इज इक्वल टू n upon V into m V square bar. And this is the pressure exerted by the gas or ideal gas. Ideal gas ज्यावेळेस असेल एनक्लोज केलेला असेल तर प्रेशर एक्झर्टेड बाय द गॅस जो आहे तो आपल्याला काय असेल P is equal to 1 by 3 n upon V into m V square bar. Now this is about the pressure of ideal gas. Pressure of ideal gas जो आहे तो तुम्हाला अशा पद्धतीने मिळेल P is equal to 1 by 3 n upon V into m V square bar, in which V square bar is the mean square velocity. Mean square speeds किंवा mean square velocity. Squares of velocity चा mean जो आहे त्याला काय म्हणतो आपण mean square velocity or mean square speed. mean squares of speed. तर squares of speed जो आहे त्याचा mean जो आहे तो काय देतो आपल्याला 1 V square bar अशा पद्धतीने मिळेल. And this is the pressure exerted by the ideal gas. Next point is root mean square speed. Next point जो आहे तो काय आहे root mean square speed. Now next point is root mean square speed. रूट मीन स्क्वेअर स्पीड त्याला आपण आर एम एस स्पीड किंवा आर एम एस वेलॉसिटी असं म्हणतो. आणि मग ही व्हॅल्यू जी आहे ती कशी येते किती येते ते आपण फाइंड आउट करणार आहोत. आपण ऑलरेडी पाहिलेलं आहे. नाउ द प्रेशर इक्वेशन वी नो दिस प्रेशर इक्वेशन इज P इक्वल टू 1/3 m upon m upon 1/3 n upon v n upon v into m c square bar m c square bar. Now this is the pressure equation. Actually this c square shows the mean square speed. C square bar gives the mean mean square speed, and the square root of this mean square speed it is called as the root mean square speed, or it is also called as the mean square velocity, and it is root mean square velocity. From this we get this relation as the c square bar it is equal to 3pv upon n into m 3pv upon n into m. But we know according to ideal gas equation we get pv is equal to nRT. By substituting this value in this equation we get c square bar. C square bar it is equal to 3 nRT upon n into m. nRT into nRT upon n into m. But n is equal to we know it is equal to n upon n. n जो आहे number of moles it is equal to n upon na. By substituting this we get this as the c square bar it is equal to 3 into n upon na into rt upon nm. By cancelling n we get this as the 3rt upon nam. But this NAM it is equal to m naught. This is the molar mass. While Na is the Avogadro number and m is the mass of the gas, or mass of the molecules. In this case we get NAM it is equal to m naught. It is molar mass. Therefore this c square bar it is equal to 3rt upon m naught. This is the mean square speed, but we want root mean square speed. By taking the square root we get this as the square root of this c square bar it is equal to square root of c square bar it is equal to square root of c square bar it is equal to 3rt upon m naught, and it is known as the VRMS or CRMS. That is the RMS speed, root mean square speed. Root mean square speed. We get this root mean square speed as like this. Actually in this book this is taken as the b square. In the old book that was the c square, but in this case it is the b square. Therefore it is the b square. Instead of this c square we can write this as the b square. Square root of b square it is the VRMS, which is equal to square root of 3rt upon m naught. Now this is the root mean square speed. Instead of this v we can also use this c, that is also the mean squares of that is the mean of squares of speed. Now I am stopping at this moment. Tomorrow we will discuss again this root mean square speed.